So this is the second video in our playlist for surface machining basics within Creo machining. So in our first video, we looked at surface milling, but probably more useful is probably the next one, conventional milling. So conventional milling is very similar. I'm going to pick a ball and mill. I'm going to pick the bottom of this raceway, and you can see it is a tilted and warped piece, so it needs to be a 3D surfacing routine. I'm going to put some feeds and speeds in here. I'm going to put a step over. Let's put it big for now, say 0.1. And then notice the cut direction. So a couple of things different here with this surface. It treats the whole surface as one. And that's usually what you're going to want with this sort of geometry. Rather than doing it patch by patch, which is what we had in our surface machining, if we use conventional milling, we get a lot more like what we want. Now, there's lots of details we can change here. So, for example, cut direction. Default is 0, which is along the x-axis of your coordinate system. Here, if I turned it to 90, right, goes that way. I could change it to 45 and go more like that. So that's conventional milling. Everything's controlled by the cut angle, but all of the surface quilts, surface patches are treated as a single entity, and it machines the whole thing. Right? So that's why a lot more popular, a lot more uses there. Let's talk about some of these other parameters in here. I mentioned like I put in a big step over. Notice I could go in and also put in a scallop height, and it'll actually figure out a more restrictive, which of these two is tighter, and figure out a step over that matches. In this case, you can see much finer. It actually matches for the scallop height. So it looks at the part geometry, looks at the tool geometry, and goes from there. All right, so you have that option. Let's just go ahead and put that back. And the default is type 3. It's a lacing combined with climb cutting. You can do one direction, basically retracts when it hits an island, goes back and start over. You have the option for line connect. If I turn that off, and let's go back to 0 maybe, so we can see this. Notice basically as it hits the wall, it retracts, come back to start over. So you don't really get the lacing, so that's why you want to put in a lace option. Line connect is what we did. Curve connect, in this part, doesn't show a whole lot of difference, but the difference would be like right here, where when it meets these arcs, it's actually arcing over as it can. In this case, it needed to do a step to stay away from the wall there, but you get the same idea. And then you can also do more of a high-speed arc connect, where it basically connects those two with arcs, right? So that looks pretty good there. So those are a couple of the important parameters. A couple of others I'll mention, or a couple of ones. Let's see, if we go up here, we have the option for over travel distance. So this is really useful in surface machining, where you've got an open area and you want to actually start on or off the part. So here I could say, give me an extra 0.2, and therefore when it starts, you'll see it actually adds some material. So it's not going to just stop with the center of the tool right on that edge. It'll go ahead and clean up past it, and that can be really good. All right, so lots of other parameters. Most of these, different. They're pretty obvious once you get into what you're machining. Depends on geometry and so forth. Obviously, you can control entry exits just like any other toolpath, but that's the basic idea. And so that's what makes up conventional machining. The main difference from surface milling is take all of the patches, treat them as one, and then machine them in a cut direction, basically as projected down from along the z-axis. All right, so that is conventional milling.